The reason why additive manufacturing was so important for us is that the walls of this engine are actually hollow. We're intending to have propellant flow through it to cool the engine. This is where it's meant to end up. We're actually taking it all the way to the bottom through this nozzle at the bottom here, and it's going to go through the walls of the engine where it cools it, and then it meets all the way back at the top with the liquid oxygen. So one really cool thing about this engine is that this is where, the extremes of physics meet. We have really hot temperatures over here, upwards of a couple thousand Kelvin, and we have liquid oxygen, which is a cryogenic propellant, at the top. So those are two extremes, and this engine is designed to have them work together to give us the result we want. The fact that we can 3D print this means that we could save a lot of time and complexity, as opposed to having people spending time, money to weld it and brace it multiple parts together. Whereas now, this is all one part, super efficient.
Well, having a partner from like Nikon SLM has been really enabled this project from start to finish. To get the process development right and for us to have trust that these parts will produce to the highest standards, having this experience with a material like Nikon SLM 1.8 for a variety of applications allows them to dial in parameters just right. And the fact that they also produce their own printing machines means that they can test those prints in-house, which in this case, these prints were made in their headquarters in Lübeck. Additive has been just a key enabling technology for us to build a propulsion system and rocket engines that we can recover and then reuse hours later. Quite low pressure drop across the chamber, which means we're ready to test at the maximum thrust, at the maximum flow rates. And one thing we demonstrated is the whole chamber is leak tight and all the flanges and all the connections work perfectly. So yeah, getting ready to hot fire in just under 30 minutes from now.
I know now why he looks like that. Let's look at it.